Alright, so we just have a short lesson today, but I would make sure you get a lot of notes because there's a lot of stuff that we're going to cover in this short lesson. At the end of this lesson, you want to be able to compare, order, and classify all real numbers. Alright, so when we talk about the set of real numbers, we can break those real numbers into separate parts. The first part being a natural number. These are your counting numbers. So for example, when my son Josh starts counting, he doesn't start with 0, he starts with 1, and he goes 1, 2, 3, 4, and so on. Those are your natural numbers. Now whole numbers are just our natural numbers, but now we're going to include 0. Integers are whole numbers and their opposite. So if I start with 0, I have 1 and -1, -2 and +2, and so forth. And lastly, we have rational numbers. Now the key with rational numbers is they are numbers that can be written as fractions. So for example, 5/7. Now you might not be super familiar with rational numbers and the idea that you can write them as fractions. When we're looking at a fraction, there's a couple different ways that we can look at it. One is that it creates a terminating decimal, which is just a decimal that stops. So 1.5, 2.75, 4.0. All those have a decimal that stops. The other one is looking at a repeating decimal. These are rational numbers where decimals repeat. So 1.3, didn't really copy with the little bars above them. And then irrational numbers are numbers that cannot be written as a fraction. They include square roots of whole numbers that are not perfect squares and non-terminating decimals that do not repeat. So for example, square root of 2, pi, just some examples of irrational numbers. So we want to write all classifications that apply to each real number. Since we have -32, it can't be natural, it can't be whole. So it is an integer, which makes it rational. So why don't you pause the video and try number 5 on your own. So this is going to be natural, counting, integer, and rational. So let's look at some more examples. Why don't you go ahead and pause the video and try these ones out on your own. So our first one is 7/4, which is the same as 7.4 repeating. Since it's a repeating decimal, this one is simply rational. How about -12? Since that's negative, but it's a whole number, it's going to be an integer and rational. Lastly, the square root of 10. 10 is not a perfect square, so 10 is going to be irrational. So here we have kind of a flow chart of classifying numbers. So the first thing you can look at is irrational or rational. Actually, I would probably start down here. Ask yourself, is it natural or not natural? Follow it up. Is it whole or not whole? Is it integer operations? Are you looking at terminating or not terminating? And it goes to rational. So all of these are considered rational numbers, and irrational is kind of off on its own leg. So takeaway is just making sure that you know how to classify these and then knowing the different terms for classification.